Hi guys, welcome to chapter 12. We're going to talk about static electricity today. Which is basically magic. Okay, so all these charges, remember we talked about atoms before and matter being made up of atoms. Let me give you a little background lesson here, okay? So all matter is made up of atoms, and we have these protons and neutrons making up the nucleus, okay? And then we have these electrons flying around the outside, and those are negative, okay? So that's where these charges are coming from. Well, those charges exert a field, and those fields can interact with other fields. And how they're similar to magnets is that like charges repel, and you can see that in this picture right here. Those positive charges are trying to get away from each other. And opposite charges attract. So if a positive and a negative gets close together, they're going to stick together, okay? They try to keep balanced, okay? Nature doesn't like things to be charged, but because these electrons are way out, kind of orbiting around the nucleus of the atoms, they like to wander a little bit, and they can cause an imbalance, okay? If something picks up some extra electrons that leave and wander away, it's more negative, so it has a little bit of a negative charge. But then if the object that you're dealing with is the object that lost the electrons, it's going to have a net positive charge, okay? And then they're going to exert those fields that then can interact with each other, okay? So that's just a little bit of background of that. So now let's apply that to static electricity and figure out why this plate's sticking to the board back there, okay? So, as objects gain or lose electrons, they become charged, kind of like I said. And it gets built up on different objects, okay? If you look at page, let's see, page 373, it'll talk more about this, but those are the three main ways that these charges can be built up. Friction being a really common one. Conduction is through touching something, and induction is just those fields being able to distribute the charges there. This is my nephew. He just went down a slide, and you can see his hair sticking up. Let's see if I can get mine to be the same. You know, it's all in the name of science, right? Is it? No? Here, let's just go directly. Yeah, there we go. Why? Because science. Anyway, his hair has become charged. As he went down that slide, he's actually leaving electrons behind. He's leaving electrons on the slide, which means he's becoming more positively charged. Well, that positive charge is climbing up and going out of his hair. And all of those little strands of hair are becoming positively charged, and they're trying to get away from each other because those like charges repel. And so they're like, get me out of here. They're also, on a lesser extent, trying to reach out to find a negative charge to rebalance themselves. And basically, if you brush your hair and you kind of get it to lay back down, it helps to balance that charge a little bit. But in addition to his hair being like that, the slide is actually charged, and you can hear the crackles sometimes when you go down a slide like that. Or even when I was rubbing the balloon on my head, I can hear some small little crackles, okay? Well, those crackles are static discharge, okay? Because these charges build up but can't flow, they balance out very suddenly, okay? You've all touched a doorknob before and had a little shock. That usually happens after you've been walking around on the carpet with socks on, okay? And the electrons are getting transferred back and forth between your socks and the carpet. I have another video that you guys should watch that explains that really well. And then as you reach out to this other material, usually a metal or something that's somewhat conductive, there'll be a sudden balance and a sudden shift of electrons. And that's a little static spark, okay? You can also see this sometimes with that static cling, okay? This is static cling. There it goes. When things are sticking together, what that indicates is that it's different charges, okay? So one thing is positively charged and one thing is negatively charged. I can't tell which is which, but I know that they're opposite because they're attracting to each other. I'm going to try to film another video with just some static demonstrations for you, and I'll show you some repulsion as well. I can't do it on this little screen, but I'll show you that later. I'll play with the Van de Graaff generator also, and when you see the spark on that, that is a static discharge. Lightning is a huge static discharge in nature. So what's happening in a storm cloud, because there's a lot of wind in the cloud, as the raindrops start to fall, these updrafts blow the rain back up into the cloud, okay? And as the raindrops are moving up and down, there's a lot of friction between the air molecules and the water molecules. And that friction is causing a transfer of electrons. So an imbalance is occurring. Well, eventually, the imbalance will be so great, it wants to balance itself again. And so this huge static spark will occur, and that's lightning. And it's balancing itself with electrons down on the ground, okay? And then thunder is nothing more than the sound of lightning, because lightning is so hot, what it does is it superheats the air, which causes it to expand, and it expands so much, it actually causes a momentary vacuum, which means there's like no air there, but nature doesn't like a vacuum either, just like it doesn't like an imbalance in charges, and so the air rushes back into place, and what you're hearing with thunder is the air crashing into itself and making that noise. But that has nothing to do with static electricity. I just think it's cool. So, fortunately, today is a really dry day. It's not very humid, and so the static experiments are going to work really well. The more humid it is, the less static there will be, because when it's humid, there's a lot of water molecules in the air, and those help the electrons find a spot, okay? And so since there's a spot for those wandering electrons to go, they kind of automatically balance themselves out, and there's just less static in the air, okay? So let's briefly talk about our Van de Graaff generator here, and then I'll do a separate video on that where we can play with sparks. This is somewhat complicated. There's lots of different videos and explanations for this, and it seems like half of them describe this globe as becoming positive, and the other half describe the globe as becoming negative, okay? It doesn't really matter, because what's happening is in the bottom of the generator here, there's this wheel, and for mine I have a crank on it. Some are electric and they have a motor, but the static isn't coming from the electricity, it's coming from the movement of that wheel. Okay, and there's a belt that's going, around this wheel. And there's a little, I think in mine it's either plastic or a metal comb that's brushing on that belt a little bit, and it's just building up all kinds of static. It's a lot of friction, okay? Well, those extra charges are traveling up, and they're collecting on the outside of this globe. Whether they're positive or negative doesn't really matter. But there is a huge collection, a huge imbalance of those charges, okay? And then when you hold this is called the discharge wand right here. When you hold that close to it, those charges automatically balance themselves out. They transfer and become neutral again. So then you can touch it, it doesn't spark at all. You'd have to build up those charges again to get that to work, okay? And it's just a fun way to demonstrate it. You guys can play this at home. It's really dry weather right now. Scoot around in your socks on the carpet, okay? Build up that charge and then touch someone and you'll feel that spark. Or if you can find a balloon, okay? Rub it on your hair and you can do it that way. This is a foam plate, not a paper plate, it's foam. And this is actually just a little piece of fur, but if you have a piece of wool, maybe even just a towel, you rub it, you're transferring electrons right now, and then boom, amazing. All right, I think that's it. See you guys later.